Hi. All of us have either been working in quantitative trading industry or aspire to work. That is why we chose this topic as we wanted to use neural networks for something related to trading strategies. So, in past, quantitative researchers have been using time series modeling tools like Arima and Garch, but there are severe limitation with them. For example, Arima requires the data to be stationary and it can't handle change in variance. That is, it can't handle conditional change in volatility. Uh, Garch model can handle volatility, but again, the error terms have only square terms. Uh, in recent time, LSTM networks have shown a lot of promise as they are very good for sequence modeling and they have huge impact in natural language processing domain. So we expect them to outperform classical time series modeling techniques. And my colleague Ewing will walk you through the classical methods, and then Han will take you through the LSTM methods for modeling.
Thank you, Akil. We applied the ARIMA and the GACH models first. These two are very classical models used frequently in the industry. Let's look at the results. This is the ARIMA model. As we can see in the graph, the model can predict the very rough trend of the price move. However, the accuracy is not so good. Let's look at the GACH. The GACH model has a much better improved accuracy. Let's look at the next graph. In this graph, you can see clearly that the Dutch model has much better results than the ARIMA. However, it's still far away from the accuracy we are seeking for. So that's the reason why we are looking for more advanced model. My colleague Han will walk you through more details about it.
Next, we'll look at how deep learning models can perform on this task. For this project, we will use long short-term memory model, which is a special type of recurrent neural network. For our univariate LSTM model, we accept input as the daily close price. This is the result for 1 day look ahead, which shows very good fit to the actual test value. As expected, the 2 day look ahead and the 3 day look ahead predictions shows decent fit, but not as well as the 1 day look ahead model. For our multivariate model, which accepts all of open, close, high, and low price as inputs, the fit does seems pretty good. However, upon closer look, we can see that the multivariate model actually doesn't perform as well as the 1 day look ahead univariate model. For the Apple stock, LSTM model seems to perform much better than classical models. Now, my colleague Akil will walk you through results for other securities.
Yeah, so as we suspected, we can see from the Apple result that LSTM based models are outperforming classical time series models. And once when we ran the model for other indices and stocks like Microsoft and Nasdaq 100, we saw similar trends. There was some interchange between the performance of Arima and Garch, but LSTM models were always outperforming their time series counterparts. So the reason behind that could be because LSTM models are able to model any kind of complexity. They are not limited to only square terms and they don't need the data to be stationary. That is why they are able to outperform. So when we talk about the broader impact, this might be the reason why more and more quant researchers are getting inclined towards deep learning based methods. And if we use these strategies, we can expect higher returns. And once the returns are higher, traders can have more confidence in such strategies. But like all the strategies in the past, once it gets widely deployed in the market, and their return will gradually diminish. So we can expect something similar here as well. Thank you.